Alright, so 5.3, the second part, we're going to talk about graphing. I have some different polynomials. We want to talk about the degree. Notice this first one, I'm not looking at the y, I'm looking at after the y. We have 5. 5 doesn't have an x at it at all. That means its degree is 0. We have a name for the type. That's called a constant. When we graph y equals 5, we end up with a horizontal line. I'm not worried, these general shape, I'm not worried about the actual exact graph, but we were going to have a horizontal line. This next one has an x, that means it's a degree of 1. We say that its type is linear. And that when we graph it is going to be a line. So the general shape will be a line, not a horizontal line, but a different line. Next, if the degree is 2, we say that that is quadratic. We just finished a chapter on that recently. So that's a parabola when we graph that. Now when we have a degree of 3, that type is cubic. The general shape of cubic is the two sides, the left and the right side, they aren't pointing the same direction. One side's pointing up, the other side's pointing down, but there's kind of wiggles, and there's a little bit different than just a line. When our degree is 4, this seems confusing. With quadratic, seems like maybe it should be 4, but that's 2. 4 is a quartic. And it looks kind of like either a W shape or an M shape. Because all of these can be flipped upside down, except for the constant. This one, we've got a degree of 5. We say that that is quintic. And it's kind of like the 3, where one side's going up, one side's going down, but there's an extra little hump in there, or wiggle, or whatever you want to call it. So it could look something like that. What we want to talk about now is end behavior. So the end behavior is how the ends behave, like the right side, the left side, whether they're pointing up or pointing down. So the right end, it's dependent upon the leading coefficient. If the leading coefficient is positive, it points up. If the leading coefficient is negative, it points down. So if we look even just at this last one, the leading coefficient there is a 1. 1 is positive, so the right end should be pointing up. And it was. I just happened to make up a picture. It's not really the graph of that picture, but we would know the right side would be pointing up like that. If it was negative, it would point down. Now as for the left end, it depends on two things. We look at the degree as well as what the right end is doing. It's a combination of those. When the degree is even, both ends, the left end and the right end, they point the same direction. So they would both be going up or both be going down. When the degree is odd, the left end points the opposite direction as the right end. So if the right side's pointing up, the left side points down. So here's an example. We've got an equation, y equals negative 3x to the 5th plus 2x to the 4th minus x squared plus 3. The degree is 5, which is odd. The leading coefficient is negative 3, which is negative. So the right end, we would start with the right end because the right side always matches what the leading coefficient is doing. The leading coefficient is negative, so the right end goes down. Now because it's odd, we know that the two sides do not agree. We've already established that the right end is going down. Since they can't agree, that tells us the left end has to point up. And I have explanations there, down because the left leading coefficient is negative, left end is up because the degree is odd, so the left end points the opposite of the right end, the opposite direction of the right end. Another concept I want to talk about here is a real zero. A real zero is just another name for an x-intercept. So if you're asked about how many real zeros, you can just look at how many x-intercepts there are, and that's how many real zeros. So I want to do a couple of examples, and then And then the back page of this will be your assignment, where you do more of this on your own. So 3 things I want on each of these. Describe the end behavior, so the left and the right end. Determine if it's odd or even based on the picture, and state the number of real zeros. So let's start with end behavior. On the first one, I've got the right side and I've got the left side. All I really need to do is say up or down. The right side, down. The left side, down. So that's just an explanation. And then that will tell me something about my degree, whether it's even or odd. Since they agree with each other, they're both pointing down, that means it's even. Doesn't ask about the lead coefficient, but I would know the lead coefficient is negative also. Does talk about zeros though, real zeros. How many times does it touch the x-axis? There's 1, there's 1, so 2. Okay, number 2. So in behavior, right and left. So what's the right side doing? The right side is pointing down. What's the left side doing? The left side is pointing up. So when we get to the degree, since they're pointing different directions, one up, one's down, that tells us that the degree is odd. It's an odd degree. As far as the real zeros, see how many times it touches the x-axis. 1, 2, 3, 4, 5. So 5 zeros. So that's really all you're going to be doing on the back side of this page. You have several questions like that. These first 6 questions, exact same set of instructions. The next 4, it's matching. You have 4 pictures, you have 4 equations, you have to match which ones go with which. And then when you get to 11 and 12, you have to sketch your own graphs based on some information that's given to you. They don't give you anything specific, so it's just a general sketch. It's not going to be exact, but make sure it matches the odd or even, matches the end behavior, and matches the real the number of x-intercepts or number of real zeros. All right, good luck.